Hello, everyone. All right, let's talk about containers. So, containers have been around for quite a few years now. By now, I'll assume that you've all heard about Docker, but if you're here, you're probably not using it daily. So, everyone says they're wonderful, but you still don't use them. Why is that? Well, for me, it was just that it seemed a little bit too complex. And I didn't have anyone to set it up for me, and really, I didn't see the benefits. I mean, sure, I heard that it fixes the whole works on my machine syndrome, but I work alone most of the time, so what's the point, right? Until I found some actual real scenarios, containers didn't make any sense to me. So, this is what I want to show you today. I'm going to go through some real life scenarios of container usage. At the end of this session, you should have some practical use cases, and I'll share with you my repo so you can actually have all the examples and run them on your own. Now, most of this will be done through the CLI because that's where we usually interact with containers. So instead of this fancy slide deck, let me just switch over to my terminal right away. All right, so I can now run this. CLI slides, there you go. So containers for developers. So yes, I've built a whole slide deck inside my terminal so I don't have to get away from there. So cool. So now we're ready to get started and we'll talk about containers. So just before we get started, let me first introduce myself. So hi, my name is Joel. I work as a developer advocate for the Red Hat OpenShift product. So we have a Kubernetes distribution that is available. You can test it out on openshift.com. I am currently based in Ottawa, Canada, but I am French Canadian, so that's the charming little accent that you might have noticed there. If you ever have any questions or if you ever want to reach me, Twitter is always the best way. I absolutely love Twitter. So my handle is Joel with 2 Lord. You can find it somewhere right there. So Joel __ Lord. Uh, of course, I usually have stickers with me. I guess if you're ever in Ottawa, just come in and drop by. I'll hand you some stickers. So let's talk about why we should use containers. There's a few good reasons. First of all, it's all about having this environment, which is always the exact same one environment. So if you work on your development environment, it will be the exact same one as your production environment. If you're onboarding a new team member, that'll make it a lot easier. Instead of having your new team member spending the whole day setting up their laptop, making sure that they have all the right software, that they have the right version of the database that you're running, and so on, you can simply hand them one command line that they'll run using Docker, and it will pull down all the required libraries and all the environment that you need to actually run that project. So you'll be able to get contributing right away. That's very important when you need to onboard someone really fast to your team. For open source projects, that is amazing. So I once had a small change that I wanted to do on a project. There was this tiny little change, and I knew that it would be an easy change to do, but it was a Laravel project, and I didn't have all of my environment ready. It was using a MySQL database, and I didn't have MySQL installed on my machine. So there's all that stuff that I needed to install in order to do that tiny little change into their code base. Now, the way this project was built is that they also had everything containerized. So what I was able to do is to simply run that Docker command and everything was started. The database was set up for me. I was able to do that change, test it out, and immediately see that it worked, and I was able to push that PR. When you don't make it easy for your contributors on your open source projects, it's easy for them to just be lazy and file in an issue instead. So make it easier for your potential contributors and Dockerize your open source projects. It's also very useful for testing. I remember working with a manual testing team for the longest time, and every single time, right, you would send them the source code and they would have a different environment because they're testing different projects. And as soon as they tried to run a code, well, something would break. And you'd be like, well, it works on my machine, so I don't see how to reproduce it. And, you just forget about it. And then you would have those typical wars between your testing team and your development team. Well, containers will help you because once again, you're shipping the whole environment with your application. So this way, the people are running the exact same thing. So in theory, everything should be reproducible now. Now, it helps you with a lot of different things, but it won't solve all of your problems. It won't help you with everything that has to do with networking, DNS routing. So if you have multiple containers working at the same time, there are some ways to do some links, and we'll kind of show you that in a few minutes. But really, if you have a complex microservice architecture, then you'll need a little bit more than containers. Containers is a good step in that direction, but you'll need something like Kubernetes to help you to do that networking for you. It also won't help you with scaling. So containers are oftentimes associated with scaling. That is not entirely true. So if you build with containers in mind, it'll make it easier for you to eventually be able to scale up. But Docker containers itself, or containers by themselves, will not help you to scale. But it will help you to make it easier to deploy more containers so that you can distribute your load across multiple containers and eventually make it easier to scale. But you'll need something, once again, like Kubernetes to help you with that. Now, this being said, what is a container exactly? So the definition on the Docker website is a container is a standard unit of software that packages up code and all of its dependencies, so the application runs quickly and reliably from one computing environment to another. It's a lightweight, standalone executable package of software that includes everything needed to run on an application, so code, runtime, system tools, system libraries, settings, and so on. So really what it is, it's basically just like a big zip file where you package not only your source code, but the executable, as well as all the required applications in order to run that software. By packaging everything into one single package, you're making it a lot easier to be able to share all of that with your different team members. It is also a disposable unit. That's a very important concept, and we'll see some examples of that later on. So once it's completed, it destroys itself along with all the dependencies, which can be great sometimes if you want to run a test environment, for example. Well, you can input as much garbage as you want into your database. It doesn't matter because everything's going to be destroyed at the end. Now you have to keep that in mind though, because if you want to persist some data, you have to remember that all of the stuff inside your container will be disposed at the end of the container's life. So you might think, well, it's exactly like a VM then. Well, not quite. There's a few little differences. When you have a VM, you have your whole infrastructure, some sort of hardware. It could be a laptop or a server somewhere, and you will have an operating system that will run on top of that. Now, on top of your operating system, you will have what we call a hypervisor. Now, I'm not entirely sure what a hypervisor is, but damn, does it ever sound cool. But basically, what it does, from my understanding, is that it dispatches the resources, or will be able to make it easier to distribute the different resources across various virtual machines. So in this case, we've got our hypervisor, and then it dispatches the different resources across 3 different VMs, and each VM has an operating system as well as all the application and all the software required to run that specific application once again. When you're dealing with containers, it's a little bit different. You've got your infrastructure, your laptop or your server, you've got your host operating system, and if you're using Linux, well, you can directly spin up new containers as other processes. That's kind of how you can see it. So that makes it a lot faster. If you need to start a container, and you'll see how fast it is, it's almost instantaneous. So it's a lot faster and much more efficient for your resources because you don't need a full operating system for each one of your containers. So where does Docker fit in there? So I've talked many times about containers, and oftentimes people will associate containers with Docker. Docker is simply one of the various tools to run containers. It is used as the base for the Open Container Initiative, so there's a standard on how containers should work, and Docker is pretty much the standard nowadays. But there's other alternatives. Podman is one of them, so if you're running a Linux operating system, you can use Podman directly, and it's pretty much a replacement tool for Docker. So there's various tools that you can use to run containers. So I promise you some real use cases. So let's look at containers in practice. The first time I actually had to use a container, and I had heard about them for a while, but it took me that little, that little extra push in order to do the research to use a container for the first time. So my first use case was one of my colleague who came to me, and I used to do a lot of PHP back in the days. Now I do a lot more JavaScript, and my examples will be a little bit of both, as you'll see today. But I had one of my colleagues came to me, and he asked me, hey, can you help me with that PHP code? Now, of course, I really wanted to help him, but I didn't have PHP or Apache installed on my machine, and all of that. I didn't want to go through that process of installing all of that stuff. But then I remembered containers, and I thought, well, you know what? This shouldn't be a problem thanks to containers. So this was my first use case. So what I did was to open up a terminal. And yes, I've built a terminal inside my slides, which runs in my terminal because why not, right? so I've got this here, and I can use docker run, which is the command that you will typically use to run a container. And let's not pay attention too much to the details of what I'm typing in right now, but you see I am mapping some port, and then I'll just run PHP 7.1 Apache. And there it is. So I've got my container running. So now if I curl into localhost 8080, you can see that it's working. I have a permission error. That's fine for now. But you can see that I have an Apache server running on port 8080. So it was that quick. You've seen how quick it was. As soon as I pressed enter, immediately the server was started and everything. And I now have a fully configured Apache server running pre-configured with PHP 7.1. How cool is that, right? So what did I do? I used docker run. So docker run will let you start a container. You just specify the image name. Now, in this case, I've used PHP 7.1-Apache. You can find a image for just about anything. There's a lot of different things. Go on hub.docker.com. That's the main resource that you will use to find various images. So if you need to run a Node.js application, for example, well, you can go there, search for Node.js. There is more likely a official image to run a Node.js server. In this case, I wanted to use PHP, so you'll give the name of the image, the version. So I wanted to run PHP 7.1. And a lot of images will come with various variants. So in the case of PHP, it can come with the Apache variant, which will have a fully configured Apache server running and pre-configured with that PHP 7.1 for me. Now I also specified the port, so I mapped port 8080 to port 80. So that Apache server on my container will run on port 80, so it's configured with the default settings. But now I need to map the port 8080 on my machine into that port 80 on the inside the container. So this is what that -p flag does. So it maps that port on my machine into the container. Now, one step that I did not do was to map a volume or to mount a volume inside my container. So what I'm doing right here with the -v flag, I'm actually taking the current working folder on my laptop, and I'm mounting that into /var/www/html folder inside my container once again. And if you're familiar with Apache, you know that this is where the files are served from. So I'm taking a folder on my machine and I mount it inside that container. There's a few other useful flags that you can use. -d, for example, will run your container in background or in detached mode. So that's what I've used there, so that you saw that long string just telling me that the container is started. But if I did not use the -d flag, you would have seen the actual logs and you would have seen the container running. --rm will let you remove the container once it is stopped, and --name will let you name your container. So if you want to do some scripting to start containers and then stop them, you can use --name to give it a specific name so you can find them afterwards. So to start a container, this is the command that you would typically use. So docker run -d, run it in the background. --rm, remove the container once you're done with it. --name, so we'll call this the my PHP. You will mount a specific folder, so I'll mount the file system or my current working directory into the /var/www/html folder inside my container. I'll also mount the port 8080 on my machine into the port 80 of the container and the image that I want to start. So PHP 7.1-Apache, which means a fully configured Apache server running PHP 7.1 in this case. Good. So let's see if we can actually get this started. Of course, I have it somewhere inside one of my scripts. So if you just give me 1 second. Okay, so there it is. So I can actually run scripts/php apache.sh. There we go. Oh, it gave me an error. Well, that's because I already had a container running. So you remember I had this container running, that 1A1E. So let's just stop this one. Docker stop A1E. And now I can run that script again. Apache. Okay, and you can see what I run here was docker run -d --rm --name my PHP. Map the port. I map the current working volume into the folder of my Apache server, and then I told them the image to run. So now if I do a curl localhost 8080, you can see that I'm getting a hello world, so I actually have access to my file. Let me just open up a new terminal window here. There we go, that's better. If I go in here in my samples/PHP folder, this is my actual PHP file, or the files that are currently being served. If I go ahead and let me just do a curl localhost 8080 again, you can see that I have the hey there world, which is not the real syntax. We should use hello world instead. So let's go ahead and change this. So we'll do a change on index.php. We'll change hey there to hello. I'll just save this. And now if I do my curl again, you can see that hello world. So immediately the file was changed. So it maps the current folder inside my machine into that container. Good, so I now have a PHP server running. You saw how fast it was. You saw that it never got into my way as well. As a software developer, I don't want to have to do all that setup. The only thing that I needed to do was to learn or to remember that very long string that you need to type. But once you know it, it's actually easier to use every time. But once you have this started, you can actually get working just as you would normally do on your local environment. You can do your changes, just refresh your browser, and you'll see your changes right away. Right, so I've used a PHP image that was pre-configured with an Apache server. You can also use PHP just as a command line tool instead. So instead of using the -Apache variant, in this case, I'm simply using the image PHP 7.1. At the end of your Docker run, and once you specify the image that you want to run, you can also add one command to get executed once the container is started. So in the next example, what I'm going to do is that I'm going to tell Docker to start a container that has PHP installed, and only the executable for PHP in this case, not a full Apache server. Once the container is started, run php/app/cli.php. So I'll map my folder, my current files, into the /app folder, and then I'll just run that script. So sometimes I like to use PHP for just to do some little scripting. I'll use either PHP or Node.js just because I'm a little bit more familiar with those than the actual bash. Bash is the syntax is I always have to Google up how to do different things. So sometimes I'm lazy. I'll just use PHP to do a simple CLI tool that I use and that I need, or just a simple CLI script that I need. So this would be a good way to actually run that example. You can also specify a working directory. So instead of running php/app/cli.php, you can specify the working directory inside your container, and then that will be immediately applied on the /app folder. All right, so if I look at my script here, I think I have php CLI. There it is. So I'm running that Docker command. So my PHP script was simply just counting the different files that I had inside that folder and just output that. So you can see that I started that container. It just ran that PHP CLI tool just to execute that PHP script, and I got the output there. So it makes it very, very easy to use different applications without installing the actual executable. If you play with Node.js instead of PHP, well, it's also very easy. You can do pretty much the same thing. Instead of using the PHP image in this case, I'm going to use Node 10 instead. Obviously, you could use whatever version that you want. I'll just use 10 for the sake of this demo. You'll notice that at the end, I also have the command to start that Node server, which will just be the node/app at the end. So let's go back to my terminal here. I'll go, let's just run that script. And it's Node server. There you go. And there it is. So I've got my Node server. As you can see, I'm running Node 12 in this case, and it's actually running. So now if I curl localhost 3000 that it was mapped to, I've got my hello world. If I look at my sample/node, index, there you go. So you can see this is the Express server that was running, and it simply served hello world on this route. Good, so once again, very, very easy to start different servers. So as you can see, no more works on my machine, right? Because you're shipping everything with your application, there's no such case as, someone running a different version of Apache or someone using Node 8 instead of the Node 12 that you're trying to test against. So really it helps to fix that works on my machine syndrome. All right, so now I tried to run that PHP script. You might have noticed that at the top there was a weird error, something about a file not found. So when I saw that error, I was a little bit lazy. Instead of digging into the code, I just reached out on my colleague on the other side of the QB and I said, hey, I'm getting this weird error message. And he said, well, do you have the file, c:/temp/log.txt? I was like, hard-coded path, like, oh no, really, don't do that. I run Linux, so I don't even have a C drive. So this is one thing that you'll need to do when you're starting to play with containers, is that you'll need to start using environment variables. In order to ensure that everybody can run the container the same way, some of those variables will need to change from one environment to another, just a little bit, and you'll be able to change them. So basically, it's a way to store a variable that is very specific to the environment in which it's running. I know I said it should always be the same environment, but you'll see how it can differ sometimes. Sometimes you might have file names that you want to be stored on your local machine. So in this case, I had a file for my logs, and my colleague had a Windows environment, so he needed to specify a different file name than I will have to on my Linux machine. Different things like a port, for example. I will obviously run my environment or my application on a different port inside my development environment than I will on my production environment. So I'll run my code on port 3000 as I'm working on and developing my application, but eventually I'll need to deploy that onto port 80 so that it's accessible on the internet. Base URLs for different APIs, for example. Maybe when you're doing development work, you don't want to hit the same API as your production API. So your base URL for your API will be stored inside a environment variable as well. So you can pass different environment variables to Docker by using the -e flag. So in this case, I'm just saying, well, base URL is localhost 8888. So that's the base URL for your API calls. To access those variables in PHP, it's very easy. So $_env and the name of the environment variable. In PHP, it's very similar, in Node.js, it's very similar. They're using process.env and the name of the environment variable. So it's very easy to access them from the code. And now you can specify something inside Docker, and then all of your application will be able to reuse that environment variable. So let's just go back here and run this little script here. So you can see here that I'm running Docker and I'm not specifying any environment variable. So I can see in the code that I have no name provided. Now in the second command that I'm running, I specified -e, name equals Joel, and I have hello Joel. If I look at the code for this specific sample, there it is. It's looking for that environment name, environment variable called name. And if it doesn't have one, it outputs no name provided. And if it does, it says hello. So this is what happened here. So when I specify the environment variable, it can actually output something different. Good. So environment variable will let us change different things into our application or inside our application and the way they work. But they can also be used to serve as some variables to start our container as well. A good example of that is running MySQL. If you have to run a MySQL database, there's obviously, there's an image that you can use available on Docker Hub. So in this case, I'm using the image MySQL 5.7. But in order to start that MySQL server, you will need to specify the root password as well as the username and password for a user to be able to access that database. And you can specify, and you have to specify all of those inside the inside environment variables when you use Docker run. Now, each image will be a little bit different. Some of them have different flags, so you'll kind of have to read up, but Docker Hub has a very, very good documentation for all of your different containers here. One thing that you can also do while you're actually looking at the documentation, you'll see that a lot of the images also have an entry point that you can use. So in this case, what I'll do here is that I'll actually mount a volume and I'll specify that the init.sql file will also be mounted inside the Docker entry point initdb.d folder and will be stored as init.sql. This way, when the container starts, it will look for any SQL files and immediately run them against our database. So that makes it very easy to pre-populate a database with a data set. So let's take a look at how to start our MySQL server now. So I'll use one of my scripts again. And I have MySQL right here. And that's it. I've got my MySQL server running now. Kind of hard to say, but I can now access my containers. So let me just do a Docker PS here. And as you can see, I have my MySQL running right here. One of the things that I can do is use Docker and run a command in interactive mode. That was in my MySQL, so the name of the container that is running. And I'll use /bin/bash. And now I'm logged in to my container. So from here, you can see that this is completely different. I am now in the MySQL container image. And I can do things like try to access MySQL. So I can use MySQL -u user, or let's use root and password root. There you go. So I'm logged into my database now, and I can list the different databases that I have and so on from here. Oh, show databases is the command. Show databases. There you go. And semicolon. Good. So you can see that I have a few tables. So I have a few tables here, but not a lot of information. So let's just exit this container and let's stop it as well. And it was called MySQL. And instead of running this one, I'll use the other MySQL script that I had right here. So this one will actually take that init.sql file and store it inside the entry point that I've shown earlier. So now I can actually log into my container again, log into my MySQL database. So MySQL-u root, password root. And now I can do show databases. And you can see that I have a new table in here. I can use presentation and select star from, I think it's conferences. There you go. So you've got a bunch of different conferences. So I pre-populated my MySQL database with all of that information right away. So that makes it a lot easier for your team to be able to share that initial set of data so that they can actually test your application and all have the same results. Here's another interesting thing that I forgot to show you here. So let's just run another script. MyAdmin. There you go. And now I can go to localhost 8888. I believe that's the port it's running on. And you can see that I have PHP MyAdmin running. I can log in as root, and password root. And I have my MySQL or my PHP MyAdmin connected to my SQL database as I've just shown. So I can now see that conference listing and I can see all the information in there and I can change the information. So it's a lot easier than to, I don't know if you've ever tried to deploy PHP MyAdmin. It's a lot of trouble, but this way was very easy. It runs it into its own container and I can just immediately stop the container and all of the files associated with MyAdmin will be destroyed. So far I've shown you a lot of command line tools that you need to remember, a lot of command line arguments that you need to remember. And this can be a lot. Like it's hard when you get started with Docker. There's a lot of things to remember. I'll share a cheat sheet at the end so you can actually use that to help you when you try to run containers. But there's also another way to make it a little bit easier. You can actually use the Docker file, what is called a Docker file. So Docker file will let you use a Docker with all the same options as in the command line, but it's a standardized set of commands that will pretty much let you build your own images so that you can share that whole image. So instead of sharing some source code and then having someone doing a Docker run and that long command there, you can actually pre-package everything inside one container and ship that to your colleagues. It builds different stacks and all those stacks will be shared. So we'll see the importance of the various stacks in just a few seconds. So what does a Docker file look like? Well, for a PHP project, it's relatively simple. So you will start from the PHP 7.1 Apache image. So you always start from an existing image. So that will be your first stack. We'll start with the PHP 7.1 Apache one. Now you'll need to specify which ports you will expose. So in this case, we will expose the port 80. That's the port that Apache is running on inside our image. And now we copy all of our source file from our local machine, so the current folder we're in, so dot, into /var/ww/html. So it will create a Docker image that will have all of that PHP image that we've used earlier, as well as all of the source code for your application. If you were to use a Docker file for a Node.js project, it's very similar. You start from an image once again, so we'll start from Node 10. We will expose port 3000. That's the port on which my application was running. You will copy all of your source code into the /app folder in this case. Then we'll change the working directory to /app. You will run npm install to install all the dependencies of your project and then run npm start. Now the order in which you put in those stacks is very important. Each one of them will create a cache that can be reused by your system afterwards. So in order to make the most out of that cache, you can change the order of those layers to optimize this. So in this case, I'll start with Node.js, from the Node.js image again. So I'll start from Node 10. I'll still expose my port 3000. So that will never change from time to time. So when I'll build my image, it will use the cache for that second layer there. Now I'll copy my package.json file into the /app folder. So my package.json file contains all the different dependencies that I need for my project, and this should not change very often. Typically, it will change a lot in the beginning of a project, but once the project is started, it should remain the same. So I'll copy that file. I'll change my working directory. Once again, it should not stop. So all this way, all the way to here, it will reuse the same cache. And now I can run my npm install, which will always be the same as long as I don't change my package.json. So all the way to here, I'm still using my cache. And now I copy my source code. Now this obviously will change from time to time because, right, that's our job, changing the source code. So we can copy that that code into the app folder and run npm start. So it will make a much better use of that cache and will be much faster next time you run it. So in order to create your images or to compile your own images, you will use Docker build. Docker build is relatively simple, so Docker build and then the path to your Docker file. So Docker build dot if you have your Docker file inside the current folder. I forgot to mention, but a Docker file is literally a file called Docker file. So this is where your Docker file is. So in current folder, and you can also specify a name for it. So you can use a tag. So I'll just call it my image and I can give it a version number. If you don't specify a version number, it will automatically give it the version latest. One thing you need to keep in mind is that your containers will or might be running as root. It's just something that you need to keep in mind. Some platforms will not let you run a container as root. I've got some more information in the link at the end if you want to take a look at this. So Docker build will let you create full custom images that you can then share with your team. In order to share them, you will use a registry. A registry is pretty much just like a repository for your source code, but for images, so it's just a place to share those images. So the image is ready to share with your team or to be deployed. So you can actually deploy all of that image with all of your source code, so with the full application into your server now. So to share those images, you can share them on public or private registries, depending on if you want to make it public or private, just for your team. Docker Hub is one way to do it. This is where most of the official images are stored, but you can also put in your own images. Quay is an open source project, so if you want to have your own registry to store your images, you can use Quay or Google, Azure, IBM, pretty much all the major players, they have their own registry available for you to use. So if your whole application is stored on Azure, then you'll probably want to use the Azure registry to store your images. To publish to the registry, use Docker push. So simply Docker push and then the name of the container. You will need to specify the registry / your username / the actual name of the image. So in this case, for my slides, for example, if I want to share them, I'll do a Docker push, docker.io / Joe Lord / my slides, or in this case, my PHP. To download an image in order to be able to use it, it's just the opposite, Docker pull. So Docker pull docker.io / Joe Lord / my PHP or / my Node.js, and you'll be able to download that image on your machine and to then see the content of that container, or to run that container if you'd like. There's a lot more useful commands that you can use. A Docker PS is the one that I've shown a few times already, just to list all the currently running containers. Docker PS-A will list all the containers, including those that are not running. So if you're not using --rm at the end, you'll see that there's a long list there. Docker stop to stop a running container. So I also did that a few times in the examples. Docker RM will let you remove a container from your system. Docker tag will let you rename containers as well, and so on. So those I've already demoed, but Docker PS is the one that you can see here. So you can see that I have all those container IDs running those different images. If I wanted to stop one, so let's say I want to stop my PHP myadmin, I can access it or use the first few characters from the ID. So Docker stop B9C, that should be enough. And it will stop that container for me. Good. Well, that's all nice in theory. But when you get started with containers, they just never behave the way you want them to. So you'll need a few tools to help you to debug them. Docker logs is one that is very, very useful. So Docker logs, the name of your container. You will see the logs of your container in real time. So let's just actually run. So we had a, clear this. We have a my PHP server running. So Docker logs my PHP. So you can see the latest request. So if I try to do a curl to localhost 8080, I believe it was running on. Yes, and then I do a logs again. You see that I've got a new entry right here, which was the one that I've just did. If you want to see the logs in real time, you can also use -f and it will just follow the logs. So if I open up a new terminal window and I do my curl localhost 8080, and quickly I go back to the other one, you'll see that there's a new entry that was just added here. So Docker logs makes it very easy to see the output of your server, try to figure out what's going on. So that can be very, very useful. Docker exec will let you run a command inside your container. So it will let you execute some command inside of your container. So you just specify the name of the image, so my PHP, and whatever command to execute. So if we just go back to this window here, we do a docker exec on my PHP, and we will use /bin/ls. And that's very important, that executable needs to be inside of your container. So that's something that to keep in mind. So if you're running a Windows machine, you'll still need to use /bin/ls because the container is running Linux. And then /var/ww/html. So we want to see what are the files inside that folder, inside my container, so I can actually see the output of it. You can also log into your containers by using an interactive command, so docker exec-it, and then you can run /bin/bash. I've done this earlier to show you the content of my MySQL image. So you can log inside your container, try to figure out what's going on, see the different things that you have inside that container, and perform various operations inside that container. To copy files from or to your containers, you can use docker cp, so the name of the image and then a path. So in this case, say I want to copy the Apache configuration file from my image into my current file system. So I can do docker cp, name of my image, : and the path to the file and where I want it to be copied. So now I can take a look at my Apache configuration, try to figure out why it's not working or whatever what is it that is not working. Once I'm done, I can copy back a file into my container. So I can use the opposite. So docker cp, the name of the file on my machine, and then the image name, : the destination inside that container. So I could change a little bit in my configuration file and copy that back into my container and test this to see if it actually works. So for debugging, Docker logs, docker exec, docker cp to help you with those. So those are all available to you. Now, if you have to run multiple containers, and I've hinted at that earlier by doing the MySQL and the phpMyAdmin images. So you can do that in a few different ways. So you can either link them by using the command line, or you can run multiple containers by using Docker Compose. So Docker Compose will take a YAML file to describe all of the various containers and how they work and how they interconnect together. So in this case, I have this YAML file that uses version 3 of the API, and it will run various services. So it will run a database, and it will use the MySQL image. I specify the ports. And then I also have a web service, which will run a PHP 7.1 Apache server, and it will depend on DB. So it will create that link between the two so they can actually communicate to each other. So I'll be able to access DB through an internal DNS service. Once you have your YAML files for Docker Compose, you can use Docker Compose up, and it will take care of spinning up all of your containers, and they're all interconnected so you can actually use that whole environment. So that open source project that I talked to you about at the beginning had a Docker Compose file, and I was able to use Docker Compose up, and it took care of spinning up a database for me, spinning up a PHP server or an Apache server with PHP pre-configured, and immediately I was able to change the source code and see this result with an initial database with some sort of initial data set in there. So, should you use containers? Well, by now I hope I've convinced you. So for your day-to-day development, well, yes, definitely, why not? It makes a lot of sense to use them. It definitely does not get into your way when you're trying to do some day-to-day development. And that was one of the things that I thought before I started working with containers. It turns out it can actually be very, very useful. You can do a lot of different things. You can very easily change the version of your application or the version of PHP that you're using, for example, or say you want to migrate from a Node 8 into Node 12. Well, how will your application react? You can immediately test it out just by changing that runtime there. So yes, definitely use them into your day-to-day development. For testing, yes, 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 definitely. It's so useful. It makes it so easy to share with your other teammates, and they have this whole environment that they can reuse, and it makes everything a lot more reproducible. Also, if you need to do unit tests, you can easily input a lot of garbage into your database, and it doesn't matter because at the end, everything gets destroyed. For open source projects, yes, yes, and yes. It makes it so much easier for potential contributors to add to your project. It makes the barrier to entry into doing those changes in your project so much easier. So definitely try to do that. If you have an open source project and you need help to containerize your application, I'll be more than happy to help you. Please do so to make it easier for your potential contributors. So that's all I had. So thank you very much for attending. I mentioned a few a few additional resources. They are all available in this link right there. So easyurl2/containers. And if you have any questions or any comments, feel free to reach out on Twitter at Joel with 2_Lord. Thank you.